Welcome everyone, I am Başak. I am an electrical and electronic engineering student. Today's presentation subject is differences between LEDs and lasers. I hope this will provide you with information about LEDs and lasers. First, we will process LEDs and then the lasers. Lastly, I want to mention about what's the differences. Okay, let's start. Firstly, what does it mean, LEDs? LEDs is an acronym for light emitting diodes. As the name suggests, LED is a diode. As we know, a diode is two-legged semiconductor circuits element that allows current flow in only one direction. How does the LEDs work? Like other diodes, LEDs have two different types of semiconductor materials, namely P-type and N-type. P-type semiconductor has positive charge carriers, and N-type semiconductor have negative charge carriers. In this way, it's possible to pass electric current through the diode only from anode to cathode. The same is true for LEDs. Unlike the standard diodes in LEDs, the electron exchange at the junction of P and N-type semiconductor causes light to be generated. This phenomenon is called electroluminescence. History of LEDs. The electroluminescence phenomenon was discovered in 1907 by the English engineer Henry Joseph Round while he was experimenting with the crystal detector dealing with silicon carbide crystals. Round has observed jitters when applying stress to certain areas of the crystal. The first LED was discovered in 1927 by Russian inventor Alaaddin. Although this invention was featured in Soviet, British, and German scientific publications, no application of this invention was used in the following years. In October 1962, Texas Instruments Company produced the first commercial LED named SNX 100. Okay, let's technology. Which areas can we use this? Offices, street and squares, building fixes, factory, in park gardens, highway and roads, historical buildings, bridges and monuments, advertising signs, site lighting, traffic signals, television and telephone lightings, internal and external lighting in the automotive industry, shipping boat, aircraft industry, carpet pitches, petrol stations, tennis courts. LEDs features. LEDs are semiconductor. LED lighting materials are silicon. When the current passes, they give light with the release of the photon. LED lighting products are produced to give light at different angles. The voltage current graphics of the LEDs are exponential. A series current limiting resistor is connected to LEDs to prevent distortion due to high current. This prevents the iteration of the non-sensitive LED's voltage range. The LEDs drop a constant voltage on it, just like a Zener diode. Red light works with 2.20 volts, green LEDs 3.30 volts, blue and the white lighting with 3.40 volts. Okay, which types we mentioned. And types of the LEDs: DC LED, AC LED, RGB LED, KOB LED, linear LED. Advantages of LEDs. First of all, they create natural light. It's more durable and long-lasting than traditional light sources. It has lifespan of 50,000 hours. LED lighting systems have the ability to work instantly. It has low power consumption and heat dissipation feature. It has the ability to dim. Dim means the light can be dimmed on, turned on. It saves energy and does not need maintenance. They are safe because they do not contain harmful gases. LED lighting systems are shock resistant. LED lighting systems do not contain mercury and are environmentally friendly. It has wide design possibilities. It has very low temperature and light pollution values. LED lighting systems are water resistant both indoors and outdoors. It gives high instant contrast and brightness. It's eye-catching and draws attention with its design. It's not forbidden to touch as there is no danger of burning or striking. Okay, second subject is the lasers. What does it mean, lasers? Lasers is an optical mechanism that enables light to be amplified by excited radiation. Lasers, whose English is laser, takes its name from the acronym of the phrase light amplification by stimulate emission of radiation. This phrase means the amplification of light by excited radiation. Lasers create photons in a current beam. The main feature that distinguishes the laser from other light sources is that the laser beam is current. It allows the beam of light to be focused on every small area and produce a single color light. Lasers can also generate femtosecond pulses, which means ultra short pulses. Okay, how does the lasers work? The working principle of lasers is based on an excitation of photons. In the slide of information, some gases are used to obtain laser light. The most common gas is carbon dioxide. When the carbon dioxide atom is excited by electricity, light, or the other means, in other words, when it's energized, the electrons of the atom are excited and pass from low energy level to high level. History of LEDs. The last laser was produced in 1960 by Theodore Mayem, based on the theories of the Charles Stones and Arthur L. Shallow. The maser, which means microwave amplification by stimulate emission of radiation, a version of the laser operating at microwave frequencies lower than light, was discovered by Thomson in 1953. The concept of excited radiation, which constitutes the main working principle of the laser, was first proposed by Albert Einstein in 1970. In 1996, Theodore Mayem obtained laser radiation from ruby crystal and proved the existence of his laser. Today, laser beam is used in industrial process, engineering, medicine, scientific research, meteorology, fiber optic communication, holography, and defense equipment. Which areas can we use this technology? In the field of telecommunications, in precise determination of distance, direction, speed, target, for example. In the field of medicine, in bleeding-free and SIMS operations. In the field of meteorology, in the weather forecast. In the production and use of energy. In the exact detection of iterations and protrusions on the Earth. In the field of scientific study and research, to send very intense energy to a very narrow area, to eliminate, to melt, to evaporate, to weld, to drill, to ignite, to initiate special chemical reactions. In the construction of faster computers in smaller size, in increasing efficiency in drug production, opening clogged veins without harming the body, used in the field of holography, for example, three-dimensional image. Laser features. Electromagnetic waves that make up the laser light proceed in harmony with each other. Electromagnetic waves that make up the laser are in the same phase in terms of the time and path. It's monochromatic light since it has almost one frequency. It's monochromatic because it's consisting of photons of the same frequency. It's in a state of light scattering very little. The diffusion angle of normal light is very large. There is almost no scattering of laser light. The exit from the source is 5 millimeters. The diameter of the laser light is 7 millimeters at 100 meters, cannot reach. It's a very strong light. For example, the flux density of sunlight. Advantages of lasers. Compared to other welding methods, its penetration is deeper in laser welding, and it can be welded faster. Since the heat input in the laser source is in a narrow area, there may be a little or no deformation and distortions. Laser welding can be used with other welding methods. Fixed segments can be welded with laser arc hybrid welding, and large weld gaps can be joined with multiple passes. The laser beam can be focused in a small diameter area. In every small and thin materials can be welded. It allows welding to made in narrow and specific places. Heat-sensitive parts may be welded too closely. Types of lasers. We have 6 types of lasers: gas lasers, liquid lasers, semiconductor lasers, solid-state lasers, fiber lasers, spectrophysics lasers. Okay, I want to mention about what's the differences between LEDs and the lasers. Firstly, portability. The advantage of LED over laser is that LEDs are a lot smaller and lighter, making it possible to make nice devices portable. Lasers are only possible with stationary systems since they require more additional electronics. Safety. Even though lasers have a higher optical intensity than LEDs, there is no heating. Artenis uses a special and unique technique for firing the lasers to make sure no heat can arise on the skin of the participants. Price. In general, a laser-based system is more expensive than a LED system. This is mainly because of the price of the lasers themselves and of additional support electronics required to operate a laser. In our system, the lasers are kept at a constant temperature, which require additional electrical elements, making the system bulkier. Measurement depth. The advantage of the laser is that you can measure deeper into tissue. With laser-based NAR systems like the Oxymon, you can place the receiver and then the transmitter up to 6 centimeters apart under optimal circumstances. Wavelength spectrum. The main difference between lasers and LEDs is that a laser has only a single wavelength and a LED emits a Gaussian-like distribution of wavelengths as displayed in the figure. To calculate the construction of hemoglobin, wavelength-specific abstraction of oxy and deoxyhemoglobin are used. Okay, that's all. Thanks for listening.